All right, so let's do at least one more. Okay, at least one more. I might do both. I might do one. We'll just play it by feel. Okay, so we've got step one here. Step one is to factor everything. Okay, so in some of my other problems, there was really nothing to factor. In this problem, though, there is something to factor. So if we look at my denominators, two of them are linear. Don't need to factor those. One of them is quadratic. You do need to factor that. So how do we factor a quadratic? Let's just do the factoring right here. I'm going to do the factoring right here. So x squared minus 2x minus 15. Okay, so there's long ways and there's slow ways to do it. We basically only learned one way to factor these, and that was the AC method. So I'm just going to do it that way. A times C, that's 1 times negative 15. 1 times negative 15 is equal to negative 15, which factors into negative 1 and 15, or negative 3 and 5, or negative 5 and 3. And actually, this is the pair that I'm looking for, because negative 5 plus 3 is negative 2. So negative 5 and 3 are what I'm looking for. So I need to rewrite this equation as x squared minus 5x plus 3x minus 15. All right, let's find the GCF of this first group here, which is going to be x. And if I take an x out, I've got x minus 5 left over. Take the GCF of the second group out, which is just going to be 3. If I take a 3 out, I've got x minus 5 left over, which means that my factors are going to be x minus 5. I can take an x minus 5 out of the whole thing, leaving behind an x plus 3. Here's my factors. So I just factored the only denominator I really needed to factor. So let's rewrite this rational expression, but with the denominator, that first rational expression shown factored. Okay, so 56 over, now instead of the factor form again, I've got x minus 5 times x plus 3. Okay, minus 6 over x plus 3 is equal to 7 over x minus 5. Let me just separate that out from the factoring that I was doing there. Okay, so there's my factored rational expression, or rational equation. Let me do step 2 now. Step 2 is to get rid of all the denominators. Does anything cancel? Anything cancel? I don't think anything cancels. I've got a bunch of linear polynomials in the bottom and no linear polynomials, only constants in the top. I don't think anything's going to cancel. So can we multiply both sides by an LCD? We always can do that. So let's do that. Let me take my first side. My left side is 56 times x minus 5, x plus 3, okay, and then minus 6 times x plus 3. Okay, so there's my first side, and it's equal to my second side, which is 7 over x minus 5. Now I've got to find some least common denominator that if I multiplied both sides by it would cancel all of my factors, okay, or all of my denominators. So what's the denominator of my first rational expression? I've got 5x, or x minus 5. If I'm going to get rid of that, my least common denominator has to have an x minus 5 in it, so that I could cancel it with that one. And it's also got an x plus 2, so my least common denominator has to have an x plus 3 in it to cancel that factor, okay? Now, let's look at this next rational expression. It's got an x plus 3 in it. My least common denominator already has an x plus 3 in it, so this is already enough to cancel this denominator out. And then finally, my last rational expression has an x minus 5 in it. The least common denominator already has an x minus 5 in it, so that's enough to cancel that x minus 5. So I think that is really the least common denominator. That's the one we're going to go with. So let's multiply both sides by the least common denominator, x minus 5, x plus 3, and x minus 5, x plus 3. Okay. Now I'm going to distribute that in to both my equations. X minus 5 times x plus 3 is going to distribute into my first rational expression. So that times 56, remember, it multiplies just by the numerator. It leaves the denominator alone, x minus 5 times x plus 3. And then it also is going to distribute into the second rational expression in this side of the equation. So I've got x minus 5 times x plus 3 times 6. Okay, and that's, I'm subtracting these two rational expressions, right? Because they are subtracted up here. Okay, and then that equals, all that equals x minus 5 times x plus 3 times 7 over x minus 5. Okay, and now I can do, finally I can do, the whole point of what step 2 is to get rid of the denominators. So my LCD should be able to cancel all my denominators. I've got an x plus 5 that cancels with that x plus 5, x plus 3 cancels with that x plus 3, x plus 3 cancels with that x plus 3, x minus 5 cancels with that x minus 5, and what do I have left here? I've got just a 56 left, minus, that's just 6 left. 56 minus 6 is equal to x plus 3. Oh dear, I've made a mistake. Let me correct this mistake. I just saw it. My mistake was this. Let's go back to this rational expression. 6 was not the only thing that was left. This x minus 5 was also left. So, I'm glad I caught that before I went too far. 6 times x minus 5 is what's left from this rational expression. And then, finally, I've got 7. That all equals 7 times x plus 3. 7 times x plus 3. Okay. Now, I can multiply. That's step 3. Multiply everything together. Nothing multiplies by 56. It's just standing alone there. But this 6 is going to multiply into the x minus 5, giving me x, or 6x, minus 6 times 5 is 30. But, of course, it's a negative 6. So negative 6 times negative 5 is a positive 30. Okay. And that equals 7 times x is 7x. 3 times 7 is 21. Okay. So now what I've got to do is, let's just simplify. I can simplify my expression by combining like terms. So if I notice, I've got a 56 and a 30 here. They can combine into an 86 minus 6x is equal to 7x plus 21. Okay, so that's simplified. Now, I need to bring. Let's do this. Let's do step 4 up here. Step 4. I'm going to bring this all up to step 4, where I need to add or subtract terms to bring everything to one side. Okay. So what side am I going to bring everything to? Well, I don't like a negative x term, so I'm going to get rid of this side, bring it over to that side. Get rid of it by subtracting an 86. Got to do that to both sides, and adding 6x. Got to do that to both sides. And that's going to give me 0 on this side, of course. That's what I'm trying to do. But it's going to give me 13x. And then I'm going to get, what is 21 minus 86? Well, 21 minus 6 is 15. And then 15 minus 80, boy, that's going to be negative 65. Negative 65, I believe. Negative 65. So now can I solve this rational expression? I think I can by adding 65 to both sides. I've got 65. 65 is equal to 13x, and then I can divide both sides by 13. 13. Okay, so I've got 65 divided by 13 is going to be 5, I believe. 5 times 13 is 50, plus 5 times 3 is 50. Yeah, so 5 is equal to x. X is equal to 5. So there's my solution. The only question is it really a solution to my original equation? Or is it just a solution to a simplified equation that I made somewhere along the way? In other words, is it my real answer, or is it an extraneous solution? Well, the way that I check that is I got to look at my excluded values. I got to look at my excluded values. And I've got to see whether any of them are 5. So let's look up here at my original equation. What are my excluded values here? Excluded values. Okay, so I can tell from this denominator that one of my excluded values should be -3, because -3 is what x cannot equal. It's got to be excluded, because that would make this denominator equal 0. One of my excluded values ought to be 5, because x cannot equal 5. 5 minus 5, that would make this denominator equal 0, so I have to exclude the value 5. And then how can you tell what the excluded values are here from this quadratic equation? Well, it's hard to tell unless you factor it, but look, I've already factored it. I factored it down here. So all I have to do is look here, and I've got x can't be 5, but I've already got that written down. Okay, so that's nothing new. And x can't be -3, but I've already got that written down, so that's nothing new. So here's my only two excluded values. It's -3 and 5. Are either of those values, do either of them make this solution extraneous? Yes. X cannot equal 5. That can't be a solution because that's an excluded value of my original equation. So 5 is an extraneous solution. So what happens when my only solution to the problem is an extraneous one? Well, in that case, since that's not really a solution, I have to say there are no solutions. No solutions to this problem. Because my only solution that I found was extraneous. It didn't actually work for my original because it was excluded. It was an excluded value.